Last talk will be happening soon. It's about to start. Hi. Hi. So, Guiltygyoza is one of the earliest and best known and best builder in the Starknet ecosystem with great experience of decentralized gaming applications. So we are glad to have Guilty, the co-founder of Topology, to give us a talk about Starknet, Cairo, and experimental FOGs. So welcome, Guilty.
Hello, everyone. Good afternoon. I'm Guiltygyoza. You can call me by GG or call me by Guilty. I am a co-founder of Topology. We build experimental games on Starknet. Today, I'm here to talk about Starknet, to talk about Cairo, and to talk about the experiments that we did. The talk will be divided into two parts. Part one will be about the ecosystem at large. I think Taiwanese developers are less familiar with Starknet and Cairo VM. So wanted to give an introduction to all of you here. And part two will be about the experiments that we did since the genesis of the company. So it's part one, Starknet ecosystem. On the left, that is the logo of Starknet. On the right is the logo of Cairo. So what is Starknet? Starknet is a ZK rollup that settles Stark proof on Ethereum. And those proofs of the proof of state diffs of the ZK rollup itself. Starknet currently is undergoing something called regenesis, which means it's upgrading its VM from Cairo 0 to Cairo 1 is a major upgrade. And the entire progress is guided by Starknet Foundation. So they're originally developed by a company called Starkware, but they are full steam ahead trying to decentralize the development of the ecosystem. And Cairo is the programming language for writing provable program using the Stark proof system. Cairo 1, so Cairo 0 is the old language, which is known as something very difficult to learn. It has the facade of looking like Python, but it's actually very low level, which is a little bit painful to write, but it's much higher level than Circom. If you write Circom, Cairo is already a higher level language than Circom. But Cairo 1 is becoming Rust-like. So if you like Rust, Cairo 1 will look very familiar to you. Not only with Rust 1 being looking like Rust, it introduces an intermediate representation layer called Sierra. Sierra is the part that is close to the Stark proof system so that you can write Cairo as a very high level programming language, just like writing Rust. Cairo is also the name for the VM. This is called Cairo VM or Cairo CPU. Question obviously would be, why Starknet, why Cairo? Why don't you just build on the world computer that is Ethereum? Well, so one of the first reasons will be if you're strange, you would want to maybe try Starknet. And one of the things about Ethereum is that Solidity feels like a web programming language. It's quite familiar to people. But Cairo was low level, so it was painful to learn and write. So you almost have to be strange and almost an outcast of the sort of the popular culture to wanting to explore Cairo in the first place. That makes you a strange person, but well, we like strangeness. One of the things about Starknet is that because Cairo was so difficult to learn, it was a filter to the kind of people that enter the ecosystem. So everyone looks strange. Everyone looks like they're thinking in very different ways than the sort of the majority of people in the rest of the EVM ecosystems. There was just like a meme about all the strangeness of people. There used to be a Lisbon hackathon about the Stark technology, and I think they rented a whole building seaside at Lisbon, and there's like bed bugs, and people smoke a lot and do like Age of Empire tournaments and while hacking away, account abstractions and play sessions that can allow you to play on-chain game without signing transactions every time. It's a weird bunch of people. And a lot of French as well. It's strangely because Starkware is an Israeli company, and they happen to be very close to French, I think, culture and language. And so a lot of weird French people. I mean, French people are kind of strange in the first place, but it's even stranger in Starknet. One of the earliest things that we did in the Starknet ecosystem was a bit strange too. So on the left, we did this physics simulation in the Cairo VM on Starknet. This is October 14, 2021. As you can see, this is simulating two rigid bodies constrained by a spring, right? It's like a junior high school physics, but we were able to write the numerical simulation of this physics system in Cairo and run it on chain, so that when you call the view function of the contract, you get the entire simulation back and you can visualize on the front end. On the right, this is November 11, 2021. We did MNIST, but in Cairo VM on Starknet. So it's like a two-layer deep neural network, ReLU activation, and it's able to recognize like MNIST digits with like 93% accuracy. And we were able to transform this PyTorch model into a bunch of Cairo contracts and put it on chain. So you essentially have an on-chain inference, ML model inference. Like it's a toy model. Number two reason why Starknet and Cairo is you're a masochist. Starknet's tooling beforehand was written in Python. It's super slow, right? So like you write a contract and the testing runs like 5 minutes, 10 minutes, and it's almost like painful. Another thing about pain in our ecosystem is that the language is very much alive and early. So imagine Ethereum, but in 2015. Solidity is fast, iterating version after version, release after release. So every time there's an update on the Cairo version, you are afraid because it breaks your program. It breaks all the abstractions and testing that you've made. But that's the fun in itself. Other reasons include you liking Rust. So I personally don't have an affinity toward web programming languages, but I like Rust in terms of sort of the control it gives you as a programmer. One analogy I like to use is that a lot of the high-level programming languages feels like automatic transmission, but like Rust feels like manual transmission, a lot of control and responsibility, but that gives you power as a programmer. So if you like Rust, you'll probably like Cairo 1. Another reason is you think long-term. So I think there's the notion that ZK proof has more potential long-term over fraud proof, over sort of game theory-based solutions. So if you think long-term about sort of the implication of ZK permeating in our society, then this is the place to be. This is where a lot of cryptographers hang out. They think about how to do recursive proof and so on and so forth. Last one is you want to participate in shaping a new computing paradigm. So what is proof of program after all? What is ZK? Analogy I like to use is that imagine I run a program and I want to convince you that I run it honestly. How would you verify me, right? One way is to rerun the program yourself and check if they match. So that's I do 1 unit of work and you do 1 unit of work, and the answer match, then you trust me. Now ZK proof basically allows me to do 1,000 units of work, so then you do 0.001 unit of work, but you can still trust me because it's basically no way to cheat with the ZKP technology. And so that shifted the responsibility, right? On the verification side, you do 0.001 workload to verify the correctness. And we know layer 1 blockchain is expensive, so let's put the verification on layer 1 and let's put the proving elsewhere. Let's make the blockchain modular and outsourcing stuff to other ecosystem. That's the modular blockchain thesis, after all. If you want to come to Starknet ecosystem, there is a bunch of open source projects. So just to go through them very quickly, Kakarot is a Type 3 ZK EVM written in Cairo completely. Beerus is a Rust-based light client for Starknet. Madeira is a Rust-based sequencer based on the Substrate framework. There is a project run by Lambda Class, which is an open source dev powerhouse, and they're making a Sierra to MLIR compiler. This basically means with this, you can run Cairo on any x86 machines. And so you can run Stark provable programs basically on any machines on Earth. Garaga is a pairing library in Cairo. So to put it simply, with this, you can verify Stark proof on Starknet. That's a pretty powerful thing. And last one is in Cairo, but in French. French people are weird. And they have a repo of Cairo 1 data structures and algorithms. It's like, the best way to learn a programming language is to do something about it. right? It's like the best way to learn a language is to go to the country and live there. Same thing. So if you want to run Cairo, maybe go to these repos and start contributing to them. By doing this, you learn the language. And all these projects are sort of collected under this repo. It's keep Starknet strange, keep-Starknet-strange. It's a strange ecosystem, and we embrace that spirit. Okay. I didn't know this didn't load, but if you want to learn Cairo, I propose a two-step process. First of all, go through Stark links. If you know Rust, there's something called Rustling. It's the Rust tutorial, sort of canonical tutorial. There's something equivalent called Stark links. GitHub, you search Stark links /Cairo 101, you'll be able to find it. It's an interactive tutorial. I think after going through that tutorial, you basically understand all the basic things you need to know to start speaking Cairo. Number two is to, this is bad. Number two is to build something and tweet. So there's some, we have this culture that if you make something on Starknet, you tweet about it and everyone will retweet it. So this is, I think the best way to learn Cairo is to go through tutorials and make something with it. Okay, is there a way to, I think this is, okay, sorry. Yeah, so this is Starkling. Well, what it looks like on your terminals is the terminal-based tutorial. And this guy is our ecosystem lead. He's a crazy Israeli guy. And whatever you do, the first question he asks is, did you tweet? Because if you tweet, he will retweet. And the rest of the ecosystem will just retweet and celebrate the strangeness of the things. Okay, so part two, we want to talk about our experimental fogs. FOG stands for Fully On-Chain Game. We started to do this in 2021. Obviously, Dark Forest was the OG of FOG. And I think recently, FOG has slowly becoming a category among the investor sphere, which is a very good thing. That means more resource and attention. But we want to talk about our experiments because I think this inspires people why it's interesting to build on a new ecosystem. So this is a recap of Isaac, which is a three-body problem experiment that we did last summer. Three-body problem, it's a sci-fi story about three suns and about a civilization that just dies over and over again, by getting burned by the sun, crash into a sun, etc. So we made this three-body problem fully on-chain game on Starknet, where we have Cairo contracts literally simulating a three-body physics problem in a smart contract, and players have to work together to solve the problem, etc., etc. This was last summer. TPS wasn't great and was unstable, so we had to pivot. So this is Mumu. Okay, so Mumu is an experiment about digital chemistry. So these are sort of formulas that you can synthesize emojis after emojis, and you want to build a pipeline that transmits emojis from the source to destination. If you play Factorial, you kind of know about building production lines that transform things and achieve objectives. This is a simulation game like Factorial. We have players playing this game and try to get high score, and this is the leaderboard. We can see a huge difference between top players and entry players. We felt that Mumu is something bigger, about something bigger. We want to find what's the bigger thing. So we went on a journey to making Shoshin. Shoshin is beginner's mind in Japanese. This is a game about making minds to battle other minds. Okay, so the process looks like this. You design a mind, and the minds provide intent, what it wants to do. It thinks about things, and this intent drives the body. Body responds to intent, and it moves around. And then you have physics that simulates how these bodies interact with each other in an environment. So what's blockchain about this? Everything is on chain here. So the execution of the mind is in a smart contract. The intent is processed in a smart contract. Bodies are represented as smart contracts, and physics is run purely in smart contracts. So core game loop, pretty simple. You as a player design and submit the mind, and then the Cairo VM executes the following loop, which is very simple. Step one, you have perceptibles, things in the environment that the mind perceives, and these perceptibles would mingle with the mind, which produces the intent, right? So like your mind processes about the environment, and your mind produces what it wants to do. Step two is intent and body mingles. So body moves around, and then there's physics simulation. And then physics simulation happens, which calculates where everyone is, what everyone is doing in the scene. And then you have housekeeping, which is calculating how much HP you have, how much stamina you have, if anyone is dying, etc. And finally, after everything being computed in the Cairo VM, we render the entire fight on the front end, so you see the fight visually. Just to go through the details a little bit, perceptibles basically means what is to be perceived in the environment, right? So there's about yourself and the opponent. And either about yourself or opponent, you can perceive about where you are, that's x, y, the velocity, vx, vy, acceleration, ax, ay, health point, stamina, what state of the body is in, what counter of the body, it's like animation counter. Okay, so after perceptible, we go to the mind stage, where the mind, perceives the environment and makes its decision. Mind is, in our current implementation, very much inspired by the Bobby Engelow's idea in GDC 17 called hierarchical finite state machine and behavior tree. It's like a way in the game industry to build NPCs, non-playable characters. So in our implementation, every mind is represented as a finite state machine where the state transition rule is a binary tree. So for example, I am in the wait mental state. Right, so if I am in the wait mental state, basically my thoughts go as follows. If my opponent is vulnerable, then I want to exploit that. I go to the attack mode. Otherwise, I stay in my wait mode. Right, so this is sort of describes sort of the part of the decision making that happens in the mind. As part of the binary tree, so we implemented this as a library in Cairo. You have essentially like an abstract syntax tree, where every node is a operator except for children. Children's are constants or table lookups values. And we have full Cairo implementation done by Greg, which is our one of our esteemed teammates. And he also did the Cairo WASM thing single-handedly. So Cairo WASM basically means we can run Cairo VM in WASM in browser. So you can do off-chain things before going on-chain. Basically running the exact same VM, but off-chain. Okay, so after the mind, we go to the body, right? So the body is your playable character, right? So imagine the mind being what the racing driver thinks in an F1 race. The body is the race car, what car you're driving. Each body is a playable character, right? So think about Super Smash Bros. Or think about King of Fighters. You have a universe of playable characters to choose from. These are the bodies. Each body is represented as a finite state machine, just like if you know Unreal Engine, this is similar to anim state machine in Unreal Engine. Now moving on to the physics side. So this is what simple physics engine do. Okay, simple physics engine basically estimates what every physics, a physics body is in the environment. So it predicts where everything is and handles collision and so on and so forth. I'm going to fast forward to early footages. This is sort of internal playtest footages. So this is how you design a mind. You sort of define the mental states that your agent can be in. You design the state transition rules. You sort of handmade every condition, sort of what goes into the mind. And we have a gameplay here. So now you see a female character sort of timing perfectly his slashes against the male character so that he's exploiting the vulnerability frame every time. This is a Phaser.js integration by one of our colleagues, Nonsense, who also built the camera control. So you have essentially camera following where everyone is in the scene. This is another gameplay where the male character perfectly blocks the opponent's attack every single time. And again, this is just replay. Everything is computed in a Cairo VM. Okay. This is sort of our interface provided for you to debug your agent. Okay, so our current focus, first of all, is to improve the accessibility. Right now, it's a little bit rough, internal playtesting. Step 2 is to re-architect everything in Cairo 1. So as I mentioned, Starknet is undergoing regenesis, Cairo 0 to Cairo 1, and we have to rewrite everything in Cairo 1, which is a very good thing because we get to think about architecture from scratch and do it in a more beautiful way. After all, beautiful code is safe code. This is just to show that the mind crunching is actually the most resource-consuming part, so we got to optimize that part. Another idea is to do application-specific VM. So this idea that our application is not just an application. It is an application for you to program behavior on top. So it's like our application is the platform in itself. And when you want your platform to be programmable, you think about putting a VM in it, right? So we think about implementing a Shoshin ISA instruction set with a Shoshin VM so that we can support different kinds of minds and bodies and game rules and maps that you play in, all on the same VM, the application-specific VM. Last thing is just to do client-side proving. So we want to prove a lot of things off-chain and submit proofs maybe recursively on-chain so you can verify it. And this way we can scale Shoshin to much more interesting agent behavior and much longer fights, more interesting physics and so on and so forth. Last but not least, we are undergoing a character concept redesign. So what you saw was Fiverr artists prototyping the art. This is the artist Guagua is in the audience that we're collaborating with. We are redesigning the entire character set from scratch. Hope you like it, the style. And this is it. This is Shoshin. If you're interested in the game or interested in talking to us, feel free to scan the QR code and join the waitlist where we have a couple strange questions for you. And if we like your answer, we'll talk to you. Thank you.
Any questions?
Is the Cairo 1 VM prover open source?
So I think that Starknet Foundation announced the prover being open sourced, but I think it's in progress. And I think there's actually open source initiative try to reverse engineering the Stark prover and to provide like GPU accelerated prover and so on. I think ZK tech at the end of the day is something that needs to be open source. Otherwise you can't trust it. So it's only a matter of soon or late.
Okay. Any questions? Okay. So I have a question. Have you ever think about go back to Ethereum?
Well, I think the blockchain now is becoming like a merry-go-around situation, right? So you have the EVM traveling to different countries and becoming parts of different blockchains, and you have the sequencer traveling around, consensus mechanism traveling around. Well, first of all, Starknet is a layer 2 on Ethereum, so it's like we're in the greater Ethereum city, just not the city itself, but the greater neighborhood. Yeah, and I think that just like video games. So video games talk about being cross-platform. You want to be able to play Fortnite on your mobile, on PS4, on different game console. I think same for on-chain applications. Mm-hmm. Eventually, things have to go cross-platform, so users don't have to care which chain they're on. This is just obvious. But I think to us, it's more important to choose where we enter so that we scale to other ecosystem later.
Any other questions? There's one.
Thanks very much for the presentation. And for the on-chain game, it's a very exciting concept. But in the reality now, it's like, especially for the gaming sector in the Web 2, it's still like very centralized. You need a lot of like experienced developers to build really interesting games. It's like different compared to the DeFi or whatever. It's a simple interaction between users. So for the game, it's a very highly, you need to have a very, I don't know, just like, I'm curious how, it's a very interesting idea, but in reality, how long do you think it takes for like the infrastructure and also for like developers to be able to really create kind of games for the on-chain? Thank you very much.
Great. So I have two thoughts to this. Do I need to repeat the question? Sure, I can repeat the question. So I think the question was, game development is a complex process. So even if we make on-chain game fully open and decentralized, there's still relatively few people in the world that knows how to do games. So how is that helping, and where does the future hold for fully on-chain games? I have two thoughts. So number one, I think Unity is a pretty easy game engine to adopt if you can suffer the foundry, all the tooling in the EVM ecosystem. I think Unity is a pretty easy tooling to pick up to make simple games. And now there are a lot of efforts into integrating blockchain with Unity. Not just NFTs, but also how do you synchronize state from blockchain into the Unity client and so on and so forth. So I think that's an entry. Definitely check out Lattice and Mud if you haven't heard. They're in the Optimism ecosystem, closer to the Ethereum city. Lattice as in L-A-T-T-I-C-E. Mud is M-U-D. Mud used to be multi-user dungeon maybe 50 years ago, but Mud is a term that they use to call their on-chain game framework for the EVM. My second thought is, I think blockchain is a new medium. And so whatever games win out on blockchain is going to look completely different from whatever games we know. And so it probably will start with something strange and lit and tiny and almost sort of conspicuous. So I think our mentality is whenever people say, let's do on-chain CS, or let's do on-chain StarCraft, we think that's not the way to go. It's just not the way to go. This medium is not built for that kind of craft. But this medium is good for something. We don't know yet. And if you like risk, if you like danger, come to the frontier and do something here. This is a wide open design space.
Any other questions?
I'm wondering, what is the target gamer for the fully on-chain game? Since it looks like right now when you need to play, when you are playing fully on-chain game, like look like you need to have the ability to maybe write some code, or you need to know maybe ZK. So I'm wondering what is the target gamer right now for the fully on-chain game, and will it be able to build a fully on-chain game for retail?
Sorry, can you repeat the second question?
Oh, my second question is that, do you think there is a way or a chance to build a fully on-chain game for the retail gamers? Maybe not today, but maybe in the future.
For the regular gamers, right?
Yeah, regular.
Yeah. Well,